In this lecture, I am going to discuss some numericals related with electric force and principle of superposition. This is the first problem. 3 equal charges plus q are placed on the corners of an equilateral triangle of side A. Then the Coulomb force experienced by one charge due to rest of the two is dash. You need to find it. So the question is, there are 3 positive q charges placed at the corners of an equilateral triangle. It is an equilateral triangle with the side A. That means each side will be A. So now there are 3 charges. Question is, find the Coulomb force experienced by any one charge. Any one charge, because all the 3 charges are of same type. So you need to find the force on any one charge, any positive q charge. So your aim is to find force on any plus q. This is your aim. Okay, you need to find the force on plus q. To find that, let us consider any such charge. Let us say we are considering this charge which is at the top corner. So this charge, we are going to consider the force on this charge due to other 2 charges. Okay, other 2 charges are plus q and plus q. And now you can see this positive q is separated from the other positive q which is on the first side by a distance a, and this positive q is separated from the second positive q which is on the other side of the triangle by a distance again a, because it is an equilateral triangle. So all the sides will be a. Now distance between first positive charge and the charge you want to find is a, and the same distance is there between the charge under consideration and the other positive q. So distance is same for both the cases. Distance is same. Now before solving all, let us write Coulomb's law. So you can apply here 3 point charges are there. So for this 2 point charge system, you can apply Coulomb's law. For this 2 point charge system, you can apply Coulomb's law. So by using Coulomb's law, you can solve it. Okay, so this is how you can solve it. First, let us consider the first set of charges, that is these 2. We are considering these 2 charges, and we will find the force exerted by this plus q on this charge using Coulomb's law. Okay, so first let us write the mathematical statement of Coulomb's law. F is equal to 1 by 4 pi. Here in the problem they are not mentioning anything, means by default the charges are placed in air. Otherwise they will mention in which medium it is placed. Here they are not saying anything, so that the charges are placed in air, so that instead of epsilon you can use epsilon 0. q1 q2 by r square. This is the general Coulomb's law. And in the given problem, you can see q1 is equal to q2 is equal to plus q. Okay, and r is equal to a. Okay, now there is an important note, please keep it in mind. Whenever you are solving problems, if in your problem you are in the diagram itself, if you are marking the direction of force, one force will be in this direction or in this direction, another in this direction or in this direction, like that. If you are marking the direction of force and then using that directions, if you are solving this problem, then don't consider the sign of the charges. Okay, if you are using this method, that means by marking directions and using directions, if you are solving problem, then don't consider the sign of the charges. So if it is plus q or minus q, you must consider that it is q. that means it is automatically plus q. Even if it is a negative charge, don't consider that negative sign if you are using this method. There is another method without using these directions, but you will use the sign of the charges also. Then using that you will solve, and finally by checking the sign of the force equation you will say whether it is attractive or repulsive. That is another method, but we will use this method throughout 12th class. You must use this method. That means using the diagram, draw the directions of forces, then using that diagram you will solve the problem. So that when you are using that method, please remember that whether it is plus or minus, always you must use plus q only. If it is q1 or q2, always it will be positive only. Don't take the negative sign. Okay, whenever you are solving using diagrams. Okay, instead of diagrams, if you are solving, you can use that magnitude and all, but here with the diagram, if you are solving using force directions and all, then you must take it in such a way that don't consider the sign, only the magnitude. Okay, now let us again come back to the problem. So here all the data are given. Now if you find the force, you can substitute all those values and you can find the force. What you will get? 1 by 4 pi epsilon 0, that is a constant. You already got it. 9 into 10 raised to 9 into q1 q2 means it is q into q. Q into q is q square by r square. R square is a square. This is the force acting on positive q, which is here, due to this positive q, which is at a distance of a. Okay, so this is the first force. So let us denote it as F1. Now F2 also you can find. What is F2? F2 means the force acting on plus q due to this plus q. What will be the equation for that? It will be same, 1 by 4 pi epsilon 0 q1 q2 by r square, where 1 by 4 pi epsilon 0 value is 9 into 10 raised to 9. Now what is q1 and q2? That is also plus q and plus q. Here no need to consider the sign, only q. Okay, so q into q, that is q square divided by again same distance a square. You can see F1 and F2 are equal. F1 is equal to F2 is equal to F. Now let us move on to the direction of force. Okay, you already know how to mark directions. In this diagram, let us again go back and draw the directions. So first thing, mark the direction of force. In this problem, on plus q which is under consideration, two other charges are exerting force. You want to find the direction of force. As I explained in principle of superposition, the force will be always acting along the line joining the two charges. So in this case, if you consider plus q and plus q, in the first case, that means this plus q and this plus q, the force exerted by this plus q on this plus q will be along this line joining, either in this direction or in this direction, either attractive or repulsive, depends on that. Direction will be either this one or this one. Here it is plus q and plus q. Plus q and plus q means both charges are same type of charges. So repulsive force. Repulsive means it will be in this direction. Okay, I'm sorry. Repulsive means, now repulsive force, repulsive means it must be in this direction. Okay, so this is the first force F1. Now what will be the second force? That is due to the second charge. Second charge means this charge is exerting a force on this charge. Okay, this is the line joining the two charges. So this force exerted by this charge on this charge will be along this line joining only. Okay, now both are positive charge. This is positive charge, this is also positive charge. So there will be repulsive force. That means because of repulsive force, the force will not be in this direction, but it will be in this direction. I hope it is clear. So force will be in this direction. You can draw the direction. That is the force due to other plus Q. So this is F2. I hope it is clear. This is the direction of force due to this charge on this charge, and this is the direction of force due to this charge on this charge, because both are repulsive force, so it will move away. Okay, so you got F1 and F2. Now there will be a resultant, and you know how to find a resultant. You already know this will be the resultant of the two forces, and that will give you the value F. Okay, so that will be the resultant. So if you know how to find F, then you will get the net force acting on the charge which is on top. If you find this F, then that will be the net force acting on the charge which is here. Okay, so how to find the resultant? For finding resultant in 11th class, in the chapter vectors, you studied an equation. Resultant of force F is equal to root of F1 square plus F2 square plus 2F1 F2 cos theta. This cos theta is also in the square root. Please remember. I hope all of you remember this equation, where theta is the angle between F1 and F2. Okay, this is the equation you studied in 11th. Now in this case, F2 is here, F1 is here. You want to find what is theta. Theta is the angle between F1 and F2, that is this angle. If you know what is this angle, then you can find the resultant. Okay, so how to find this angle? That is the next question. What is this angle between F1 and F2? From the geometry itself, it is clear. Angle between them, because it is an equilateral triangle, this will be 60. This will also be 60. This will also be 60. So these three are 60. If these three are 60, then what conclusion you can make? Then this will also be 60. So angle between F1 and F2, theta is equal to 60 degree. Okay, so theta is equal to 60 degree. Now you can find the force. Force F is equal to, write the equation, root of F1 square. F1 and F2 are same. Okay, that is F square plus F1 is F, F2 is also F square plus 2 into F1 into F2, that is F into F. F into F is F square. 2F square cos theta. Cos theta is cos 60. This term is also in square root, please remember. That is equal to root of F square plus F square, that is 2F square plus 2F square cos 60. What is cos 60? Cos 60 is 1 by 2. Okay, so 2F square into 1 by 2, that is root of this 2 and this 2 will get cancelled. So here you will get 2F square plus second term 2 and 2 will cancel and only one term will remain. This is root 3F square. Root 3F square is nothing but root 3F. So the resultant force is root 3F. That means root 3 times the force due to one of the charges. Okay, so that is the resultant force acting on plus Q due to other two charges. It is equal to root 3 times any one force. I hope it is clear. In the same way, you can solve for other charges also. That means instead of the charge on top, you can find the force on any other charges due to the rest of the charges. In the same way, mark the directions of force, find the force, then find the resultant using the equations. Okay. Now, instead of a triangle, 4 charges can be placed on the corners of a square of side A, and there can be questions like find the force on any one charge due to other 3 charges. So for solving that also, you must follow the same method. Consider that charge and imagine that you are standing on that charge. Then look on the other charges and draw the direction of force vectors. Then from the diagram, find the resultant force direction. Then using the equations, you can find the resultant force. In all these problems, please remember that whenever you are doing by considering the diagram, direction of force and all, please remember that don't consider the sign of the charge. If it is plus q or minus q, always consider that it is plus q or q. Okay, if it is minus 2 microcoulomb or coulomb, don't consider that minus sign. It is 2 microcoulomb or coulomb. Like that you must consider on whenever the problem is solved in such a way that you are using the force directions. Okay, other than that, if simple numerical you are solving, you can use the sign of charges also. But when you are solving using diagrams with force directions and all, and using vector addition and all, then in that method don't consider the sign of the charges. Okay.